Hi, everyone. Really excited to talk about what it means for a language model to preserve privacy today. So, I am but one author on this wonderful paper. Some of the other co-authors will be there present at FACT, so please go and say hi. So, language models, model language. What does that mean? Language models learn a probability distribution of a sequence given the previous tokens. So I have a probability of a word given all of the previous words. For example, you could say the probability of the completion. The students open their books, maybe high probability. Students open their laptops, maybe also high probability. Maybe students opened their bikes would be a low probability example. Bikes don't usually need to be opened. But there's a problem. These large models are often leaky. So what we mean by that is sometimes the training data can be memorized by the models, and then when you are asking the model to complete a sentence, you might get that back out. And that's been true for these large language models like GPT-2. Here's an example of one instance of that, where we got back someone's phone number, name, and address. That's why sometimes these language models are called stochastic parrots. They're parroting back the information that they were trained on. Other types of attacks that you might imagine are like extraction attacks, which is what we're showing here, or membership inference, like if you have an example and you're trying to determine if that example was present in the training data or not, or a snapshot attack. So in order to understand what privacy means for language modeling, we should back up a little bit and talk about how we use language. And when I say how do we use language, I really mean like, what is language used for? And it's used to communicate our ideas, our wants, our needs, to form identity and community, and to express ourselves. So the difficulties with language and the privacy concerns that raises are as broad as those of real life. Let's talk about an example. So we have Alice and Bob, and Alice turns to Bob and says, "I'm getting a divorce." Bob says, "Oh no, what are you going to do about custody of the kids?" So Bob has inferred, with the additional information that Bob has about Alice's life, that divorce means that something's going to happen with the kids. Maybe Bob then turns around and says to Grace and Charlie, "Did you hear that Alice is getting divorced?" And Grace and Charlie go, "Oh, Alice is getting a divorce? No way." And so depending on the relationship that Bob, Grace, Charlie, and Alice all have with each other, this might be something that Alice is comfortable with or Alice is not comfortable with. So if Alice is going to tell Grace anyways, and maybe she understood that Bob and Grace are really close, maybe she's not surprised to hear that Bob had already told Grace. If, however, Alice and Grace aren't on good terms, then maybe this is a violation of their privacy. But all that is to say that instead of forgetting this information, we memorize the information that Alice is getting a divorce and then judge whether or not it's appropriate to share based on the context. In other words, privacy is contextual. And the problem here is that language models don't have this understanding. The information that you need for context is usually beyond the data that we have collected. So, another way of saying this is privacy is not binary, it's contextual. You can't just say this is private information, this is not private information. And why that's particularly important is because we sometimes talk about like public information that you get online or private information in someone's like text messages, for instance. So a framework for thinking about contextual privacy is called contextual integrity. And this breaks it down in 5 different parts. So this is previous work by Helenius and Baum in like 2009. So you can have something like a data subject, which in this case is Alice because it's Alice's secret. The sender, which is also Alice, Alice telling Bob, the recipient. And the information type might be the text about Alice's divorce, and the transmission principle is that the recipient won't share the information with anyone Alice isn't close with. So we can see how we can break down any scenario into these different components to determine if this information flow is something that the sender and the data subject would be okay with. So preserving privacy in language modeling requires that we only reveal this private information in the right context to the right people. So we have to define what that context is, to define what the information is, and which people are in group. So in the second part of our talk, we'll talk about the two current private NLP methods and maybe where they fall short. So one example is text sanitization, aka why can't we just remove private text? This is hard because private information doesn't have just one format. So for example, you've been on many academics' websites and they, instead of writing out their email exactly, they say something like last name at website.com. So scraping that information out might be a little bit difficult. Additionally, you could write like, instead of the social security number, writing like the number 22, you might write out TWO, TWO, and that would be much harder to scrape. Language also constantly changes. So words change meaning. Obviously, this happens with like big current events, but it also happens as cultural shifts occur, like die to unalive. Privacy is also extremely context dependent. So we're throwing Bob a surprise party. Can't tell Bob. So another one is differential privacy. And differential privacy is adding some noise is a method of training a model where you add some noise so that the probability of a single example being in there is indistinguishable from the probability that it's not. And differential privacy is a little bit complicated because it makes a lot of assumptions. To better understand why those assumptions might not hold for language, let's return to this example. So in this case, we've got Alice and Bob is turning around to Grace and Charlie again. So the private information here belongs to Alice, but we've observed a couple of problems in this example already. Alice has shared that information with Bob, and then Bob has turned around and shared that information with Grace and Charlie. So to preserve Alice's information, we need to do something about the data that's in Bob's account, and then now in Grace and Charlie's account as well. So drawing a border around where the in-group is can be a little bit challenging. It's not just user-based. Okay, now let's take a different example. So did you hear Alice is getting divorced? Let's switch that out to, did you hear that Alice is in a custody battle? So if Bob says that to Grace, Grace might infer that means that Alice is getting divorced. But Bob hasn't explicitly said to Grace anything about a divorce. So trying to find the border of the secret, the knowledge that Alice is getting divorced, can be pretty challenging because that information can present in many different ways. And it might not be a continuous stream. You might not be able to follow it all the way around. Cool. So additionally, one of the assumptions of differential privacy is that information that is repeated many, many, many times wouldn't necessarily be private. So for that, let's turn to a different example. So the Panama Papers, there was a group of 300 journalists that were all talking about the Panama Papers for a year beforehand. So Panama probably occurred way more times in that conversation than usually occurs. So if that is repeated information, that still should be private within that larger group, but not to the entire world. It shouldn't be public to the entire world. So this idea of where the border of shared information is, again, presents, and also the number of repetitions that you need also presents. So we're not saying that differential privacy doesn't meet the guarantees that it provides based on the assumptions that it has, but we are saying that differential privacy makes a lot of assumptions. And those assumptions don't always hold with our ideas and our conceptions of privacy for language. So how can language models preserve privacy? Well, that's pretty challenging. So the first thing is we should probably get consent for including people's data in these data sets. One person's data could include many persons' information, though, as we saw with Alice, Grace, and Bob. So getting that meaningful consent can sometimes be pretty challenging. So Informed consent, kind of hard. Doesn't mean we shouldn't do it, but it is kind of hard. Another thing we wanted to talk about was how publicly available does not always mean publicly directed. For example, your data can be shared without your consent. If you had like someone copy paste your chats and post it publicly, that doesn't mean that you wanted it to be shared. So it's kind of an adversarial situation. Also, public posts on social media often have target audiences. So if you're posting in Reddit, you probably have a community that you're focused on and not, sharing it to everybody. So the trouble here is that language models risk sharing data at a broader scale than the users originally intended. So how do we make privacy-preserving language models? Well, currently, it seems like a meaningful way to do this is to either train on data that's intended to be public, and then maybe also fine-tune locally on user-contributed data, and maybe keep that on device if possible. Cool. Thank you, and I wanted to leave you with a couple of questions to think about, maybe to discuss in whatever groups that you have, either at work or at school. Thank you.